we are moving to module 6. So plane waves in medium. So we know that conductors have conductivity equal to infinity. And dielectric means they are like insulators. So there are different types of dielectrics, namely you have lossy dielectric, you have lossless dielectric, and even free space is a dielectric. So you can see in the classification of plane waves in medium is into 4. First one is good conductors, where conductivity sigma is infinity, the permittivity epsilon is equal to epsilon 0, and mu is equal to mu 0 mu r. The condition is sigma greater than omega epsilon. The second one is lossy dielectric. Lossy dielectric means the conductivity sigma is not equal to 0. There is some conductivity. It is not equal to 0. Permittivity is epsilon and permeability is mu. In perfect dielectric or lossless dielectric, conductivity does not conduct at all. So conductivity sigma is equal to 0. Epsilon is equal to epsilon 0 epsilon r. Mu is equal to mu 0 mu r. And free space is also a dielectric. So sigma is equal to 0 in free space. It does not conduct at all. Epsilon is equal to epsilon 0. Mu is equal to mu 0. The characteristics of EM waves, there are 3 characteristics. First one is they travel at high velocity. Second one, while traveling they assume the property of a wave. Third is they radially outward from the source. An EM wave has 3 material constants, namely sigma, epsilon and mu. Sigma is the conductivity, epsilon is the permittivity, and mu is the permeability. Today we will be considering wave propagation in a lossy dielectric. So lossy dielectric is a medium which is not a perfect insulator. It conducts the EM waves for some extent. That is why you are saying sigma not equal to 0. Okay. So now you will consider a charge-free lossy dielectric medium. So charge-free means charge density rho v will be equal to 0. So now we are writing the time harmonic equations. First one is Maxwell's first equation, that is del dot Ts is equal to rho v. Since rho v is equal to 0, you can write del dot d equal to 0. Since d is equal to epsilon e, you can write del dot epsilon e equal to 0, or simply del dot e equal to 0. Mark it as equation number. Second one is del dot b equal to 0. B is equal to mu h. So del dot mu h is equal to 0, or mu h is equal to 0. Mark it as equation number 2. Then you have third one, del cross E is equal to minus j omega b. So b is equal to mu h. So you can write del cross E is equal to minus j omega mu h. Mark it as equation number 3. Now the last one is del cross h is equal to j plus j omega d. What is j? J is sigma e. What is d? It is epsilon e. So del cross h is equal to sigma e plus j omega epsilon e. Grouping the terms together, you get del cross h is equal to sigma plus j omega epsilon into e. Mark it as equation number 4. And these 4 equations have been derived from the Maxwell's equation. Now taking curl on both sides of equation 3, you get del cross E is equal to del cross minus j omega mu h. Okay, mark it as equation number 5. Now we are applying the same identity to del cross E. That is del cross A, or vector A is equal to del dot A minus del square A. So you get, applying that, del cross E is equal to del dot E minus del square E. Now we can see the LHS of equation 5 and 6 are the same. So comparing those two equations, you get del dot E minus del square E is equal to minus j omega mu into del cross H. Now you have to substitute for certain terms. So you can do it as del dot T minus del square E is equal to minus j omega mu into del cross H. We have already defined in equation number 4 as sigma plus j omega epsilon into E. So substitute that. So you get del dot E minus del cross E as del square E is equal to minus j omega mu into sigma plus j omega epsilon E. Mark it as equation number 8. So from equation 1 we know that what is del dot E? Del dot E is equal to 0. So minus, you will get on simplification you get minus del square is equal to minus j omega mu into sigma plus j omega epsilon into E. Or on further simplification you get minus del square is equal to minus gamma square E, where gamma square is, we are grouping all these terms together as gamma square, so j omega mu into sigma plus j omega epsilon, and gamma is known as a propagation constant of the medium. So this equation, wave equation in terms of electric field is getting modified as del square E minus gamma square E is equal to 0. Del square E minus gamma square E equal to 0 is known as the wave equation in terms of electric field. So similarly we can derive the wave equation in terms of magnetic field intensity, that is del cross H is equal to, how can you write? You can write it as sigma plus j omega epsilon into del cross E, and again applying the identity, equating both sides, equating both the equations. On simplification you get minus del square H is equal to minus j omega mu H into sigma plus j omega epsilon, or minus del square H is equal to minus gamma square H, or del square H minus gamma square H is equal to 0. This equation is known as the wave equation in terms of magnetic field intensity. So you can see the propagation constant gamma is a complex quantity. It is consisting of two parts, a real part and an imaginary part. Gamma is equal to alpha plus j beta. Alpha is known as the attenuation constant and beta is known as the phase constant. Also gamma is having another equation, gamma square is equal to j omega mu into sigma plus j omega epsilon. So from this, on solving for gamma square you can get the real part of it. So the real part of gamma square, okay, so for obtaining the real part of gamma square, take the magnitude alone. So that will be magnitude of gamma square is equal to root of, because it is having two parts, so root of sigma mu omega the whole square, omega square the whole square, plus sigma square mu square omega square. For taking omega mu outside you get sigma omega mu into root of sigma square plus omega square epsilon square. So this will be the magnitude of gamma square. From that you can get the real part of gamma square as minus omega square mu epsilon, or also you can simplify, directly find out the real part of gamma square. How? Gamma square is equal to j omega mu into sigma plus j omega epsilon. Open the brackets, so you get j into sigma omega mu plus j square omega square epsilon mu. So this j square is nothing but minus 1. So you get minus omega square epsilon mu plus j omega mu sigma. So from this, what is the real part? The real part of gamma square will be this term alone. That is why you are writing real part of gamma square is equal to minus omega square mu epsilon. So mark it as equation number 18. Okay. Also we know gamma is equal to alpha plus j beta. So you are taking the square so as to equate. So gamma square is equal to alpha plus j beta the whole square, or alpha square plus j square beta square plus 2 alpha j beta, or this j square becomes minus 1, so it becomes alpha square minus beta square plus j into 2 alpha beta. So the real part of gamma square will be or the magnitude of gamma square will be root of real part the whole square plus imaginary part the whole square.